Hi everyone, I'm Aysun from Protocol Labs, and I'm super excited to talk about how decentralized protocols are shaping the future of web and data infrastructure. As I've been focusing more on this topic, I realized how much we, as users, take it for granted when things work on web, when it comes to data, storage, reads, writes, and so on. But when they don't work, it's pretty frustrating. Web3 has been growing and evolving, but many of the Web3 apps that we use today, unfortunately, are relying on centralized cloud infrastructures. Good news is that the new ways of interacting with data have been becoming more accessible. They are not only transforming the way that we use data and interact with it, but also challenging our preconceived notions of the web and its capabilities, especially breaking down the data and identity silos. Today, I will touch on briefly the history of the web infrastructure, where it is going, and what some exciting future use cases look like. Before talking about how to get there and the future use cases, let's first take a step back and look at the evolution of the web. And we will quickly realize it's not about Web 2 versus Web 3. Rather, Web 3 represents an inevitable evolution of where we stand today about web and latest version of the web, which is called Web 2. And if we go back to history and look at the very beginning, when it started first with the internet, it started with the wired up computers to transfer files from a point to point. Later in the Web 1 era, when establishing servers was much easier and cheaper, we had much less data, and many of the informational websites, read-only static websites, were created. Changing the content relied on the owners of the servers, and it was not so easy to do so. The Web 2, which is considered as today's internet, introduced the right in the hands of users. But it comes with the dominance of the certain platforms. Platforms like Facebook and Twitter allowed us to create and share content much easier, but within their own platforms. Should I use that one? And the custody of the data is now in the hands of those platforms. Although it's very convenient and helped the decentralization, democratization of the internet technology, it had some natural consequences that pose trade-offs and risks for all of us. To touch some of the issues that we face in Web 2 today, that we are increasingly seeing the data is being centralized, owned by certain players and platforms, and people lose access and control even for their own data. It creates lots of data and identity silos. For example, your picture on Facebook doesn't show up on LinkedIn. If you wanted to do so, it leads lots of duplication and inefficiencies. And verifiability of the data are in the hands of platforms. Today, Elon Musk and Mark Zuckerberg get to decide the verifiability of most of our data on social networks just by themselves and their teams. So we might not have a problem with it until it's our own data and it's our problem. So as we think about this evolution of web, and as the web becomes ever-growing part of our day-to-day lives, we need a better version of it. Which is when the rise of Web 3 started. The intention is to return the data and control of the internet back to the hands of users like you and me. This is something very new, but there's a lot of innovation and lots of resources being poured into it. And it's really happening right now as we speak. One of the most significant areas Web 3 is making a mark is in the realm of the cloud data infrastructure, which is what I would like to touch today a bit. But before getting there, you might ask, why this is all tied back to the data? Because data is the backbone and foundation of everything we do with the internet, and it's growing fast. IDC, International Data Corporation, predicts that the global data sphere is expected to be more than double in size between 2022 and 2026. So as the web evolved from 1.0 to 3.0, data storage and infrastructure have been trying to catch up and shaping the foundation of this evolution. So let's take a quick look at the history of web data infrastructure. First, as you will see on the left-hand side, before the emergence of cloud infrastructure, data was typically stored on physical servers. This meant that companies had to invest in their own IT infrastructure and manage the service themselves, which could be very expensive and time-consuming. Set aside, it's very exclusive. And then the concept of cloud computing, cloud infrastructure began to take shape in the late 90s and early 2000s with the rise of application service providers. In the mid-2000s, AWS emerged as one of the first cloud computing platforms, offering a suite of web services that allowed companies to store and manage data remotely. Google and Microsoft, not surprisingly, soon followed suit with their own cloud computing offerings, and the market for cloud infrastructure began growing rapidly. And today, these three companies dominate the most of our cloud infrastructure. And over the past decade, with the start of Bitcoin applications and the launch of decentralized protocols like IPFS and Filecoin, the way we interact with the internet moved towards a more open, decentralized, and trustless experience, hopefully for all of us. Right now, we are at the cornerstone where the future of web is being shaped with the arrival and rise of distributed web. So you might ask, like, what is distributed web, or how does it compare to where we are today? So here you will see on the left-hand side, Web 2, the way that we interact with the web today is a model that is mainly around centralization, which means that data is controlled by a few powerful companies. While this happened and resulted from the needs we had at the time as we evolved from Web 1 to 2 and helped the internet to be more easily accessible by so many others, it came with some drawbacks. Some of the problems that we see are single point of failure, which can pose lots of systemic risks in big industries like finance, vendor lock-in, high cost to switch from your cloud provider to another one, and need to trust a few centralized authorities, lack of transparency, increasing costs, and in addition, cloud infrastructure is often subject to government surveillance and censorship, as governments can force companies to turn over data or block access to certain websites or in certain locations. But on the other hand, as you get further removed to the distributed system from centralized, you get to see your services' resiliences increases because users themselves are now the ones who are powering these services. So how do we build a more distributed web? How do we get to a world that we have more resilient, performant, scalable, efficient, secure, and censorship-resistant web, enabling all these Web3 applications rather than relying on cloud infrastructure that is available today in centralized manner? So the answer starts with something called content addressing, a new way of storing and interacting with data. But before going into details of how content addressing works, let's take a look at how we are interacting with data in Web 2 today. So today, we use something called location-based addressing and client-server models. What we do is when we save a file, we can do it locally on our machine that mainly goes to a specific path on our drives, or we can do it through web, but it's not that much different indeed. Because when we open a website, we are just opening some files from a certain location. The difference is that that location is now remote, and the files are downloaded from a remote location. And we do it using a browser that makes things easier for us. On the other hand, content addressing is a technique for organizing and locating data in a system in which the key used to locate content is derived from the content itself, rather than its location, which is called Content ID, CIDs. And IPFS is a decentralized open protocol that leverages content addressing to store files. Now, with IPFS 2, we are also obtaining files from a remote location. But it leverages content addressing without relying on where the data is. So the key difference is that we don't need to know where the data is located or call the data with the location, but we need to know the content ID. Ultimately, the content can be at one or several locations, but it doesn't matter anymore where it is, as long as it is somewhere else. So in essence, IPF is a distributed system for transferring data. So if you want to dive into a little bit of more how content addressing works and how this becomes possible, we will see in order to be able to do content addressing, we need to create the content identifiers for each piece of content that we want to put in the network. Think of this as kind of cryptographic fingerprint of the piece of the content that you have. These fingerprints derived directly from the file and the file's its content using an algorithm that will always generate the same one for the same content. This ensures verifiability of the content and that the content hasn't been changed. So every piece of the content produces a different fingerprint. And this fingerprint that we call CID can be reproduced anytime from the original content by hashing it. So this means if we obtain a piece of information or content after requesting through CID, we can verify that we were given exactly what we were asking for. The fact that a CID will always represent exactly the same piece of information, unlike a location that can change, this unlocks the capacity of doing verification of any piece of data. That matters because if the CID is guaranteed to give you the same content, you don't have to get that content from a trusted centralized server anymore. You can ask for that CID to anyone in the network, and you don't need to trust them. So to recap, when we think about content addressing versus location-based addressing, you will see how they are compared to each other. As you can see, in the Web 2 way of interacting with web and addressing data, you check the data based on an address that might not have the data you are looking for anymore. It's like sending a postcard to a friend, looking at their home address, but they might have moved out from that place and you get to send it to someone else. However, through content addressing, you call the data from wherever it is with its own ID. So IPFS sounds great, right? And it's really useful to anyone who wants to serve or retrieve content on the web, which is almost everywhere. As certain pieces of the content gets more popular, the data becomes more readily available. And as you see, you can run your own node, you can create a network of nodes, but ultimately, using IPFS just by itself in the wild might not be enough, because IPFS does not provide an inbuilt incentive system for storing data on behalf of others. So you might ask, why would random people help store my digital content? So the answer is they would likely not, which is why at that point you might need to pay to someone else to store your content, and with that you would lose kind of the beauty of decentralization and trustlessness. So then, is there a decentralized and reliable alternative? The answer is, fortunately, yes. And this is where we start talking about Filecoin. Filecoin was introduced to guarantee the long-term storage of files with crypto-economic incentives and further expanding to retrieval and compute. And Filecoin leverages IPFS. You can think of Filecoin as a distributed storage marketplace. The Filecoin network enables open services for data and adds an incentive layer to IPFS. It's a global digital economy that leverages the Filecoin blockchain to operate as a settlement layer for the data services. The ultimate goal is to enable the composable integration of these services in order to build a decentralized infrastructure that can credibly replace the current centralized clouds. So, as you see, IPFS and Filecoin is not about either or. They are great complements to each other. Because Filecoin commoditizes storage, while IPFS allows for flexible retrieval of data. Filecoin uses cryptographic proofs and economic incentives to make sure data is stored as promised. Using IPFS with Filecoin, you can future-proof your storage. The magic of IPFS content IDs is that they are a property of the data itself. So it's storage layer agnostic. Think of it as like IPFS, for example, IPFS enables a single URL to reference through CID, let's say your NFT, and even if the content lives in many locations, meaning with the same CID, your NFT can be secured and stored on your local computer, AWS, as well as decentralized storage networks. This matters because then it means you can pursue multiple storage strategies at the same time in parallel, and even if one breaks, your NFT, your data is going to be okay. And here you see the diagram of the Web3 enabled architecture. As you see, what we talked up until now, the storage layer is at the very bottom of this whole diagram, meaning it's very foundational and very foundational for the full web architecture, but it's just the beginning of it. So we are only scratching the surface in this topic. There are lots of opportunities for innovation, and as you will see, as we go up layers, there are so many more other things that we can do. One layer up, you will see we have storage helpers, aggregators, on-ramps that make it easier for an app developer to plug into the centralized storage network rather than dealing directly with IPFS and Filecoin storage deals. And then we have the logic layers, that orange building block, that is super important because it's the bridge between end-user-facing applications and the data protocols, unlocking the new ways of interacting with data cross chains. And the logo on the far right side, you will see, it's the logo of Filecoin virtual machine that is launching on March 14th, in 2 weeks. It's fully EVM compatible. Smart contracts will enable locating storage, compute composability, and also enabling cross-chain messaging for hardware services for the first time. So there are lots of opportunities as this new way of interacting with data opens up new possibilities for all of us. And this is what I'm really excited about. And it's really not about decentralization for the sake of decentralization, but because we can do better, we can build better web, better world, better products, using all this available technology to us and building on it. Here you see some of the very important and exciting potential use cases. Some of them are already being built on Web3, some are on Filecoin already, and some are being integrated with FVM. So if you touch on some of the very important ones, I think top 3 are the ones that have been lots of innovation and progress. Identity management and data ownership. So imagine a world users can bring their own data to the apps without replicating, duplicating, and without knowing who knows what about them. So healthcare is a great example of this, owning your healthcare data and ability to bring it to different portals, different hospital portals, healthcare providers, with the ability to decide what to share with whom. AI training models is also super critical and important because it's very important for us as we think about what AI models are going to generate for the future. It's important to have unbiased, inclusive, and transparent data sets. And CIDs can really help to make sure data is not altered, it's open, and we can confirm how inclusive those data sets are going to be. Decentralized science is another area that's very important, and with this new technologies that I discussed, we are working on building, and we can do it more so, creating public infrastructure for transparent and equitable scientific research and data management. One area that's very exciting for me is, again, healthcare, creating and monetizing valuable data sets. And there are so many other examples that we can build on those the first 2 layers of foundation of Web3 data infrastructure, DAOs, gaming, and many other industries that are going to be enabled by new business models and transparency. So as you've seen, it's a journey, and this is just the beginning, which is good news. While we have come a long way, there is still a long way to go. Just as with many other areas of technological development in the history, it takes years of iteration and improvement to reach the key milestones. We need to be patient for the long term, but also impatient for the short-term impact that we can start creating today. As I wrap up, I would like to highlight some of the key principles that I think we should keep in mind and focus as we shape the future of web. Decentralization. As I mentioned before, not for the sake of the decentralization, but really because we can create better web and products using it. Collaboration and community building. That's super important, and something that I'm sure we all have seen how different Web3 compared to traditional Web2 industries. It's key to sustain growth of Web3. It will drive adoption, innovation, and it's going to create and help us having a more transparent and unbiased ecosystem. Trust and security is another one that we should cultivate it more through educating our users and businesses, not only the current one, but the future ones, so that they know how to expect, what to expect, how to use, and we can help to minimize the abuse of the new users that are just joining Web3. Privacy, that is not to be overlooked at the expense of cool products, because it's very important that we make sure we are building our products around making sure the privacy is there. And last but not least, user friendliness. that more users can benefit from Web3 and create value through use of Web3 apps. It's really important for us to make our products more user-friendly, intuitive. Therefore, we can cultivate the ecosystem, having more users that they can unlock more value and build on top of those layers further on. So thank you, everyone, for listening to me today, and thanks to Denver for the opportunity to speak. I hope this talk got you more excited about the future possibilities that we can start building in Web3 data infrastructure. You can find more information on IPFS.io, Filecoin.io, and feel free to connect me on Twitter @IsonDemircan. Thank you.